back to SQ5, Solving Quadratic Equations, Part 5. If you missed 1 through 4, you might want to go back and catch up on those. This is just a little side version there. There's a special case of trinomials as far as factoring goes, and these are called perfect square trinomials. There's a formula for these, and you can actually factor these without knowing the formula. The formula just makes it a shortcut. The reason this segment is important is because later on we're going to have to create perfect square trinomials to solve an equation. So you need to be aware that they exist, and you need to know how to recognize them. So real quick, let's just talk about these for a minute. Let's look at this trinomial. If I were going back through the analysis like we did for the other ones, I would see it is quadratic, it is 3 terms, it is an easy trinomial because there is no coefficient in front of the first term. So all I would have to do to factor it with a chart is make a list of the numbers under here that multiply to give me 16. Let me start over. 1 times 16, 2 times 8, 3 won't go, 4 times 4. I'm going to pick the pair that adds up to give me this. Now I can create my binomials. I know it's going to be x and x because that's where I got x squared. Since these two are plus signs, I know I'm going to have plus and plus. Now here I'm going to put the 4 and the 4. You can actually write this as x plus 4 squared since these are repeated. Alright. Now let's just look at this one. Same thing's going to happen here. When I multiply 136, 2 times 18, 3 times 12, 4 times 9, 5 won't go, 6 times 6. 6 and 6 is going to be the pair that adds up to give me that middle term. So when I write my binomials, I'm going to have x and x. Since this is a plus sign, I've got plus and plus. And then 6 and 6. This could also be written x plus 6 squared. So that's our special case here, is when you wind up with 2 binomials that match. These come from a trinomial that's a perfect square trinomial. So let's look at the formula, and I'll show you how to recognize one. These are the formulas for a perfect square trinomial. And a squared plus 2ab plus b squared equals a plus b squared. And then one with minus. This is the only difference between the two formulas, is that the top one has a plus sign here and here. The bottom one has a minus sign here and here. The only difference. Everything else is the same. A squared means there is a perfect square in that first position. B squared means there's a perfect square in that position. The hardest part to recognize is this middle one, because what 2ab actually means is 2 times the square root of your first term times the square root of your last term. Now, if you have a perfect square trinomial, then all you have to do is take the square root of the first and the square root of the last, all squared, for your answer. So let's get a trinomial, and let me show you how to apply this to the trinomial. Here's a problem. X squared plus 20x plus 100. Let's go through the mental analysis. We need to factor this, and we see that it's a trinomial. We see that it is quadratic. We see that we have no coefficient in front of the first term. Yes, I could use the chart, find all the multiples, but using the formula, if it applies, is just a shortcut, and I know y'all are all about these shortcuts. So, first you have to see, does it match the formula? Well, this is what you look for. Is the first and last term a perfect square? Well, x squared is and 100 is. So that matches my formula here. Next, is the second sign a plus sign? Yes, it is. Those were easy. Now the middle part is a little bit more difficult. The middle part of each formula has to be equal to 2 times the square root of the first term times the square root of the last term. So let's see. Is 20x equal to 2 from here. The square root of my first term is x, and the square root of my last term is 10. Is 2 times x times 10 equal to 20x? Yes, it is. So yes, this is a perfect square trinomial. So I wouldn't have to make a chart. All I have to do for my answer is take the square root of the first, whatever sign this is, the square root of the last, all squared. So that's how you apply it. Let's look at one more. Let's take this new problem and let's see if it fits the case of a perfect square trinomial. So what are you asking yourself? Are the first and last terms perfect squares? Well, 25x squared is all a perfect square. 4y squared is a perfect square. So number 1 is a check. Next is that second sign, a plus sign. Yes, it is. This sign can be whatever you want to. It can be positive or minus, but the second sign must be a plus sign. Then the middle term. Is this middle term equal to 2 times the square root of this, which is 5x, times the square root of this, which is 2y. 2 times 5 is 10, times 2 is 20xy. So yes, I have a perfect square trinomial here, and to apply the formula, all I have to do is square root of the first term, 5x. Since this is a plus sign, I've got plus. Square root of the last term, 2y, all squared. And that's your final answer. As usual, there's a practice sheet to go along with this. I will leave the link in the description box, okay? And we're fixing to go solve quadratic equations in the next one, so come back. Bye.